Hi folks, I hope this finds you doing well. I wanted to show a demo of the next big feature for Illuminated Cloud. It's something that I think a lot of people have wanted for a very long time. It's also something that Salesforce is actively working on right now, so hopefully everyone will have access to this feature soon. It's support for TypeScript as a logic language for Lightning Web Components development, in addition to, of course, JavaScript, ES6, ECMAScript. Probably use that term interchangeably throughout the demo to just mean JavaScript as used in Lightning Web Components. Before we get started, I want to put a disclaimer out there, and that is that I consider this feature to be beta level. It's actually very mature. I think you'll see that bear out through the demo. But the reality is that the standard library for Lightning Web Components development, basically the things that the services that are available independent of a project, it's just not 100% formalized yet. Salesforce has published out some type definitions, very small subset, and they've documented it. And I've captured all that information, or as much as I could. I'm sure it's still missing some, in the form of kind of formal definitions. But my guess is there are omissions, there are things that are not quite right. For the things that are documented only, things like intermediate type names where you have composite types and things like that aren't necessarily expressed as formal names. Just they're described. So I've come up with formal names, but they may not be exactly what Salesforce lands on. The good news is I started a dialogue with some folks at Salesforce today in hopes that we can have some collaboration on that to make sure that there aren't hugely divergent paths before we converge. But regardless of what happens, I will plan to maintain backward compatibility with what I have here. So if I have named something, a type something, and then basically Salesforce puts the canonical version out there and the name's not the same, I'll leave the old name in place as an alias to the new name with the deprecated header with guidance to the new name. So it's not going to break, but certainly over time I'm imagining that there will be quite a bit of guidance-based redirection from what will end up being deprecated names that were just guesses. Hopefully I got a lot of them right too. But there are almost certainly omissions and such here as well. And I'm talking again about the project independent standard part of this. And I've cleaned it up very well from what I've been maintaining for this purpose. I've segregated into distinct modules and namespaces and things like that. But I imagine it's not perfect. I know it's not perfect because every new project that I ported, I kicked over a couple of new stones. And you certainly are using corners of this that I'm not. And by the way, as long as we're talking about this, if you're familiar with the offline symbol table in Illuminated Cloud, you're familiar with how it generates a project-specific SDK for development. It's doing the same now for TypeScript or even JavaScript-based Lightning Web Components development. This needs to be stored in the file system because the TypeScript language service and TypeScript compiler need access to it. So it's not just in a zip. So instead, it's in a directory that's automatically excluded, automatically added to force ignore and get ignore, called .illuminated cloud. And then under that, structured is LWC types, which, as you can see, is automatically added as a library root to the current project. And this is generated when the project's open, and it's maintained as the corresponding project metadata changes. I'll even show that in the demo. But it includes not only the standard library kind of extracted out, but other things that you would have access to, like R-enabled Apex methods and properties. And you can see here, and we'll circle back around to this in terms of inputs and outputs and what those mean. Content asset and resource URLs, if you had custom labels, you would see those here. Message channels, and in this case, again, I'll show more on this later, but not just the message channel type for import, but also the shape of the payload based on the metadata. The field IDs and object IDs, so you can work with schema dynamically, but also similar to the OST, the actual S-object definitions, so you can work with those in a first-class sense. And I'll even show that in just a moment when we show an improvement that we made while porting this particular project over from JavaScript to TypeScript in one that has already been ported. The rest of the demo will actually be porting a component in its test, but I'll be able to show an example of this. So hopefully you get the idea that this is, you just think of this as being the offline symbol table for TypeScript and JavaScript development in Lightning Web Components, and it has to be in the file system, and Illuminated Cloud takes care of it for you. Okay, so having said that, the process I went through while working on this feature in order to verify it, validate it, like I said, kick the tires on it, so to speak, is I ported a set of Lightning Web Components projects from JavaScript to TypeScript. And that includes my own side project, hobby side project that I alluded to in the local dev server demo previously. I'm not going to be demoing that, but I am maintaining that completely in TypeScript now. So that's pretty good evidence of where we are. And then several of Salesforce's own open source reference implementation projects for Lightning Web Components. So the one we're going to use for the demo is going to be e-bikes, and then there's Dreamhouse, and there's LWC recipes, and I've even made some progress on e-cars, but it's not finished yet. And the e-bikes ported repo, I actually have this fork. That's why it says e-bikes LWC SEW. And I've actually I'm making that available if you want to take a look at it. The release notes for this feature will include a link to the GitHub repo, the fork of it, and there are multiple branches. There's kind of the original branch, unmodified. There's one where I added, without any porting, just all the IC stuff, the project files and things like that, so you can see what a configured IC project checked in looks like, at least from my perspective. And then the one that includes the entire port. Now there's another branch called demo. I don't know if I'll actually leave that around when this demo is done, but really it's the same as the last one I mentioned, the ported one, except one of the components has been backed out and put back into its original form in JavaScript. And in fact, I think it'll be interesting just to show a diff. Why don't we do that? So I'll actually diff just against main. This is exactly what you would see that we're diffing against if you just check this right out from GitHub, at least as of yesterday or day before or something like that. So like I said, I added the IDE project files, but for the most part, what we're going to see here is that Git is going to think these are renamed. Some are going to have just enough differences. It doesn't seem to be a rename with just a couple of differences, but most of them are going to look like this. They have the differences that you would expect. And that is effectively as you move from vanilla JavaScript, which is inherently untyped. You can add type information via type-based comment hints or comment-based type hints and such, to a statically typed language. It's part of the language grammar. And we've added data types. And as we needed, we've imported those data types if they're not in the default namespace. Some of these didn't actually end up with any differences at all. Some of them ended up with some differences. By the way, errors. I think if you're familiar with this, errors can take many forms. That's actually what LDS utils down here is all about, is digging into an error. Is it a fetch response? Is it just an array of strings or a single string? And trying to suss out what it is. So sometimes you just have to punt to any. Hopefully not very often. But one thing I do want to point out here is there are going to be times, this is beta software, there are going to be times where you have to suppress a false positive from one of the static code analyzers. And there are several static code analyzers in play here. There is, of course, the commercial JetBrains ID. And by the way, you're not going to get much benefit here of trying to do TypeScript development in one of the free community edition IDs. It's supported. It's not going to break or anything, but you're not going to get any of the static code analysis and tight integration with the TypeScript compiler and tight integration with NPM and Node and dependencies and such. You're just not going to get that. And really, that's the benefit of moving to a statically typed language, is having all that additional static code analysis going on. So everything I'm going to be showing is with Illuminated Cloud being used with a commercial JetBrains ID that has first-class support for TypeScript and Node and NPM and TypeScript language services in the compiler and all. And in this case, one of the static code analyzers is, of course, the JetBrains IDE. Another one's Illuminated Cloud. Another one is the TypeScript language service. That's what reported this. Another one's ESLint. And in fact, the suppressions here are kind of a result of the last two. TypeScript language service said, hey, add tsignore to this. And I did. And ESLint said, hey, don't add tsignore, add tsexpectError, and add a description of why you expect an error here if the suppression's not here. So you're going to have a lot of collaboration going on here from a lot of different static code analyzers, but you get the point. Sometimes you're going to have to suppress something. Now, let me say this. I've configured tsconfig.json that gets generated for your project to be able to handle imports of JSON data files this way. And that's actually really cool. We'll show that in the demo. I haven't quite figured it out for HTML. I am not a TypeScript or tsconfig expert. If you are, or if you're certainly more knowledgeable than I am and you know how to fix this, let me know. If it gets I'll go ahead and incorporate it in the next build. And if it gets incorporated, I'll be happy to acknowledge your contribution. And the same goes not just for this kind of stuff, but if you look at my kind of massage standard library, or even the ambient definitions I'm generating for the imports, the project-specific imports, and you see opportunities for improvement or things that need to be fixed or omissions, and bring those to my attention, let me know. And I'll be happy to acknowledge your contribution to something that I think everybody will benefit from. Just keep that in mind, and I may circle back around to that. So having said all that, and that little warning that came up will come up in just a second. It's because I hovered over something. Having said all that, we've kind of seen the diffs here. Why don't we go ahead and start the actual demo and start porting? So I have this component. And like I said, I backed out it already being ported to TypeScript. And so it and its test are still JavaScript files. And you can see that in a few different ways. You can see that the tabbed editor shows it as being JavaScript, and its test is .js. We can see that because this is inferred as being a JavaScript-based component, and I try to insert additional bundle files, it says, well, those logic files should be JavaScript. Whether they're client-side logic files or additional Jest tests, they should be JavaScript. But if we go to step 1 of porting and I just rename .js to .ts, several things happen. So one thing is Illuminated Cloud now sees this as being TypeScript. Now, it didn't port the test. We're going to do that ourselves. It's not going to port things completely for you. But if we start trying to add new logic files, it sees that they should be TypeScript. And it's not just within a single bundle, by the way. If you want to start creating new TypeScript components, and by the way, it should be possible for both TypeScript components and JavaScript components to coexist in a single project. You don't have to bring them all over kind of in a single pass. You can bring over what you want. You can just start creating new components in TypeScript, and Illuminated Cloud should support that. So should Salesforce. I'll elaborate on how that works a little bit more later. But if I create a new component, there is a new field here. It's unchecked, which is going to be the default, and it's going to work exactly like it has. It's going to be JavaScript. If I check it, then it's going to generate based on a file-based template, just like there are file-based templates for all the different metadata types you can create. There are new ones for all the different TypeScript files, TypeScript main file, TypeScript supporting file, TypeScript Jest file. And of course, it's going to remind you that this is currently beta level. And if you say OK, it's going to remember whatever the setting was for the next one. So assuming that you choose TypeScript, it's going to assume, or not assuming you choose, if you choose TypeScript, it's going to assume that you want to continue using TypeScript. If you're not using TypeScript, it will assume you don't want to. So very easy to create new components and create new files for existing components of the correct type. Now, the other thing you may have noticed up here is it's saying that the TypeScript dependencies are not installed. Well, I've told you already that Illuminated Cloud is going to create a bunch of stuff like the standard library and the project-specific library portions and things like that for you. It also is going to look and see if all the different dependencies are installed. So the package.json that gets created for a new project when created via the CLI includes a bunch of stuff, but it has no idea about some of the, at least right now, some of the things that are required for TypeScript, for ESLinting a TypeScript, for compiler, for things like that. So Illuminated Cloud is going to help you get there. And by the way, this supports both source format and metadata format projects. It's just going to have to generate a lot more stuff for metadata format projects, so all the scaffolding's there, because it still needs to use npm. And you can see that it made some changes, and so now that went away. And what are we left with? Well, we're left with 12 weak warnings. Now, the reality is some of these are warnings, some of them are suggestions, things like that. And really, the next step of the porting process is to go through those and address each one in turn in some fashion. And the way we're going to do that is we're going to use navigate, next highlighted error, and if necessary, previous highlighted error. And the key bindings for these are going to be the same in all the supported operating systems. This is one that doesn't vary across operating systems. So I'm just going to go over here, and I'm going to hit F2. And I have the presentation assistant on. For some reason, it's not showing the Mac key binding here. I'm not going to restart the demo. I've done it twice already. I'm not going to restart the demo. It's enabled. I'm not sure why it's not working, but this is F2, Shift F2 on all supported platforms, and this is really the relevant one right now. So the first thing that we come to is actually saying that this field doesn't have an explicit data type, and it doesn't have a very strong implicit data type. Right now, the best it can get is any. And we can see, again, implicit data types like page number during its initializer is set to 1. Tiles are draggable set to false, up here false. These, the static code analyzers can infer a data type based upon the initial assignment. But this one it can't. And in fact, let's see what data type it can come up with by bringing up context actions. Now, this is something that's quite important here. You're going to get context actions from several different sources. I already mentioned that there are several static code analyzers in play. So the first 3 about code generation, the last 3 about changing visibility are coming from the TypeScript plugin for the commercial JetBrains IDE. The middle ones are coming from Illuminated Cloud about local dev server. We'll see some from Illuminated Cloud that have to do with type inference as we kind of just move on through this demo. Right now, it doesn't have anything useful here because you'll see in just a moment. Then there's a third category here, and there'll be a fourth later. The third category, this little icon TS, means it's coming from TypeScript language service. And effectively, the commercial JetBrains IDE is engaging a hot instance of TypeScript language service behind it and is constantly polling it for suggestions, for static code analysis feedback, and things like that, and folding that in with what it does itself. And so that's the only one that has anything to do with type here. So let's go ahead and see what it says. Well, it was only able to infer a type of any. And the reason is there are no usages. Oh, well, there's Mac OS. I guess it didn't show the distinction earlier because there was no distinction. How interesting. Okay, well, good. So if I do something where you want to know the key binding, it'll show it across all platforms. But there are no usages here. There are no usages in the HTML template. There are no usages in JavaScript or TypeScript. So as a result, it can't figure out what type this is. Now we know that something called page size is almost certainly a number, and that's certainly made even more concrete by its own comment. So let's just do that and move on. Okay, so now we get a wire decorated field, and it's being wire decorated with the message context from Lightning Message Service. So let's see what our context actions are. Well, again, we get a bunch of them, but now here's one from Illuminated Cloud saying, hey, based on that wire decorator and based on all this that I know about that, it's message context type. So if I hit enter, we're done there, message context type. Moving on to the next one. In this case, TypeScript language service says, hey, I can infer something useful here. And it did, message channel subscription. And we can even look at how it got there. So this field is being initialized down here, or being assigned off of the return value of the subscribe method, and we can see that the subscribe function that was imported returns a message channel subscription. So based on that, it was able to infer a concrete data type. Okay, so let's move on. So now we have one that's another field that's got a wire decorator that wires it to the Aura-enabled Apex method called getProducts. And so let's see what it says. It says we're going to set products to the wire data type wire result paged result. You may not be familiar with those two data type names. If you're familiar with Lightning Message Service, you probably know these. These are probably new to you, or at least new to you from this context. I'm going to elaborate on what they are by looking at how we got there. So we brought in getProducts, so we'll go ahead and look at the import for that, and that imports the Apex product controller getProducts method. So let's just open product controller, and I'm going to drag it to the bottom. Here we are, and what we're going to do, I'm going to drag this up a little bit, give us a little bit more room, and let's just look at what we have here. So the original method, product controller, is R enabled, and it takes as input a filters value object, which is basically just a series of R enabled properties of various types, and an integer page number, and it returns a paged result. And we're going to see something very similar up here. getProducts takes a product controller.filters, so it's actually retained the inner class kind of syntax here, product controller.filters, and then it takes a page number that's a number. Now, there are discrete numeric data types in Apex, decimal, integer, double, long, things like that. They all translate in TypeScript and JavaScript to number. So this has been canonicalized over to number, or I should say normalized, maybe a better term there. And it returns, now of course these wire adapters return a promise that upon success will resolve to a page result. And then obviously on failure will return an error. Okay, so we can see a lot of parallels here. And so filters, we can see what that looks like. Let's look at what product controller.filters looks like here. Well, again, product controller.filters, and we see that the Aura enabled properties, the only ones that are going to make it across the wire, have been translated. They've been search key as a string, max price is a number because it was a decimal, and the other three are string arrays, and all of them are optional because there is no first-class notion of optional versus required in Apex like there is in TypeScript and in ES6 and in Kotlin and things like that. So to avoid other potential issues with whether things match the contract, we're just making everything optional when it generates. So that's the input, and then for the output page result, we'll look here. And then we'll look here and see if there are parallels. So again, this is a value object in Apex with several properties that are annotated as R enabled. So page size, page number, total item count are all integers, so those become numbers. And records is an array of objects. So that is one of the few times that we want to see any here because again, it's untyped. So a direct translation. And Illuminated Cloud is actually pretty darn good about this translation. At least I've tried to make it good. You may find that it's not in certain circumstances, but it understands composite types, even recursive composite types, so self-referential types or mutually referential. If it does paint itself into a corner, it will just punt to any. If you see something sent to any that's not like object being translated to any, please let me know and provide an example of that because I want to fix that. The goal is that the API you end up with in TypeScript for the inputs and outputs, the way you interact with your R-enabled Apex, that effectively they act as direct analogs. And I mentioned earlier that Illuminated Cloud is maintaining this library because this is over here in this library. It's maintaining it on the fly. We can see that right now. I'm going to comment this out and I'm going to save, and in just a second we should see that page size just disappears, and it did. And I'm going to bring it back and I'm going to save, and we should see that it comes back. And that's going to be true for all of the metadata types that end up being importable into Lightning Web Components via these kind of Salesforce specific import module types. Okay, so having said all that as a fun little side project or side quest, let's come back over here. And so we've already made this Y result page result, so we know what that is. And now we can see like usages of products. Even in HTML, we're going to get strongly typed. So products dot, and we can see that now we get back a data that's a page result and an error that's a fetch response. And the data has these fields just like we saw. And the records being an array has a length property. So we can actually interact with that way. For the thing we're passing in filters, it's actually this variable up here. We know that that's a product controller dot filters, and by virtue of adding that type, we can now, if we wanted to fill out the data, can start filling out the data in a first class, very strongly typed manner, and everything holds together. All right, so let's move on to the next one. So next, we are subscribing to a message channel. We're using a message service to subscribe to a message channel. In fact, we're subscribing to this message channel right here. And this is our callback that we get, our listener that we get when a message is actually published on that channel. And so we can get a data type for that. Illuminated Cloud will suggest a data type for that. So I mentioned earlier that we end up with payloads for our message channels. And so let's bring up right here, message channel, and I'm going to split this down again, and let's just look at it. So we end up with products filtered because that's the name, that is its API name, and it has added the kind of name of it, the master label and the description as documentation text up here, and then for each of its Lightning message fields, which are inherently untyped, it's added an optional field of type any, and it's added the documentation header on it as well. So you're going to end up with, as strongly typed as you can, a payload for a message channel that you can interact with, and we can see now that if we say message dot, we know about filters. So we could start to dig into that particular message payload. Okay, so let's move on to the next one. And now we're moving into the world of event handlers, and Illuminated Cloud can help you here as well. So this event, let's just look at what it is first. This event is a custom event raised on a custom component, and so it's going to call this method. So what does Illuminated Cloud say about this? Well, it offers two options. One is an LWC custom event parameterized by the custom component type, and there are times when you'll want to do that. And the other is product select event. I don't know what that is, right? So let's take a look. Where did that come from? So if we again follow the breadcrumb trail here and say, okay, well, this is called by onSelected. The onSelected property here, the onSelected event handler, is when the selected event is raised. A custom event is created for selected event, and it's going to correspond to the payload. And you can see that when I ported this particular component, which has already been ported, I gave it a concrete data type, and that concrete data type is really just an alias to a parameterized custom event, because the data for this, the detail for this, is just a string. It's just a product ID. We set this to product.id, and product.id is in fact just a string. Is in fact just a string. Evidently I didn't get that quite right, but it's just a string. And so we end up with this strongly typed event. So we can now deal with that. If I didn't want to do that, let's go back over. And let's get rid of this and see what it comes up with now that we're not using that concrete type. And we can see now it's using the object literal, the deconstructed type. Again, it's going to be strongly typed in terms of what we deal with. We now know that detail is of type string, but we're not dealing with a name type. We're dealing with an anonymous type. So let's just go back to product selected event. We'll go ahead and have that be asserted to be a product selected event. And now we're very strongly typed. Okay, so going back over here, let's move on to the next event handler. And this event handler is being invoked on a Lightning input, so a standard component, and it's an on-change handler. And Illuminated Cloud says, okay, well, we can make this a custom event parameterized by the component upon which the event's being handled. And so custom event Lightning input. And what we're going to see is we just ended up with another error. Now, we're going to circle back around to this, but this is an event target from the event object. For some events, so custom event has a detail, and that detail, as we just saw with the custom event I raised from that other component, that is strongly typed. It's parameterized by the custom event type parameter. And we can even see that by changing that to detail, that I see exactly what you'd expect, the lightning input value, the value of the lightning input component, which is really what we want. It was what they entered into the lightning input. And so this is theoretically what we want. We're going to leave it like that, but I want to put a pin in this and say we're going to come back to it. And then the last one we have in here is this parameter, and it's saying, hey, we can probably infer something better. And the reason it can infer that is because it's being invoked up here with a strongly typed piece of data, so we know what the data that's going to be passed to it is. And now we're green. We're done here. Okay, so the next thing that we'd want to do at this point is test it, verify it. So run the test. But before we run the test, let's port the test. All right, so let's go over here, and we have our test. And again, coming back down here, it's a .js file. And there are a bunch of warnings and weak warnings, but there are no errors or anything. So let's rename this file, the first step to porting one of these, and let's see what happens. Well, now we have a bunch of errors as well. So let's see what these are. Again, let's use our good friend F2 and just kind of go through them. So we're going to get a couple of recommendations here now from 3 different sources. So the TypeScript plugin for the JetBrains ID is all these above this splitter. So the big one is convert required or import. And then TypeScript language services is suggesting the same thing. And then ESLint is actually the one raising this error, and it's saying, let's go ahead and just suppress this if you think this is right. So I think what we're going to do is just convert this into an import. And I mentioned earlier that I had imports working for JSON data files, and in fact that's what we're doing here. These are just JSON data files. So I have imports for those working, and so we'll look at what happens. But let's move on to the next error in order, and it's another require. So we'll go ahead and change this one, but I'm going to tell you right now this one's going to cause an issue. So we went ahead and changed that one. And we're going to move on to the next one. And here we're importing get products, the same R-enabled Apex method that we imported in the actual component. We are importing that, but we're using mock methods on it. In this case, we're using like the Apex test wire adapter mock methods on it. And while at runtime, there's a lot of magic that happens with LWC Jest in order to make it so that your imported modules end up becoming mock instances of those. TypeScript knows nothing about that. It has no idea. All it knows is that get products is this, and that this doesn't have an emit method. So again, Illuminated Cloud can help here. It knows when these errors occur, and it can help with type coercion. And it offers a couple of different options. You can either use assertion-based or you can use the as syntax. I personally like the assertion-based, so I'm going to go ahead and accept this one. And you can see that it went ahead and said, you think you know what get products is, but it's actually an Apex test wire adapter, and now we actually get access to emit. Okay, and so let's go to the next one. And so we have more of these. So we can actually apply these wholesale. So I'm going to choose the first one, and I'm going to say do all of these, and we just went from 17 to 3 up in the right corner. So now we go down, and as I mentioned, we're now importing that mock get products up here. We're importing that as a JSON data file, but actually imports it as an object literal. So it's not just a string, and it's effectively saying, hey, this is already a number. Why are you treating it as if it's a string? Parseint takes a string and a radix. So we can go ahead and get rid of parseint here and just treat this as a number. And so because page number here is in fact a number in that object literal. And so there we have it. And so let's move on to the next one. Okay, so we have a couple of instances coming up here where we're getting access to elements, to components dynamically. In this case, we're creating one on the fly. We're creating one based on this component name, this kind of its name as you would use it. And then this looks like it should give type information about what the return type should be, but it's really just the constructor that's going to be used to create the element, to factory it. So it's not going to affect the return type, but in my version of the library, create element, just like query selector and query selector all, is a parameterized method. In Illuminated Cloud, as you just saw, can help you to infer the correct component type, the correct element type from what's being created, and parameterize the call. And now search bar is visible is actually immediately available because it knows that that's a product tile list. And the very next one's going to be similar, except instead of create element, we have query selector, and similar with query selector all, which is obviously going to return you a list instead of a single one. And instead of using a component name, this is actually using a selector expression. And that selector expression, if we look over here, is actually on, we'll go over to the HTML, is actually the class of a lightning input. Okay. And so what we're going to do is use that same context action, and it says, oh, well, okay, what you've queried is a lightning input. So Illuminated Cloud is actually evaluating that selector against the HTML template of the component, and now we have the right type, and again, we get back to lightning input.value. Okay, so all the red's gone. Let's see what else we have left here. So here's not a warning, but a suggestion saying that you can convert this into an async function. This is coming from TypeScript language services. I'm going to save us some time. I'm not going to do these yet when we see these, and that's all that's left in here except for this. And I'm also going to ignore this for a minute. It's going to go away in just a second. It's basically saying that it doesn't know how to use create Apex test wire dapper because it's just a constant in this import. It's not fleshed out. Again, the standard libraries are not completely formalized. But I think the thing that we can do is we can go ahead and run tests. And I think we're going to get one failure that's going to short circuit, then we're going to get another failure. But I'm going to run all the tests for the project, which is going to include all the components and tests that we've ported, even the one we just did. So let's see what happens here. And we ended up with one failure. And if we look at where that failure is, it's basically with create test wire adapter. So I mentioned that we would end up with an issue here. And it's basically saying, at least my interpretation is, that we want to continue to use require with this. So I'm just going to revert that to its wire form, and then we end up with an unused import we get rid of, and we end up going back to red, and we go to red for the exact reason that we did that change to begin with. And in this case, we know that it breaks things, so we're just going to suppress it. And now we should go back to no red and just some yellow, and we're going to run our tests, and we're going to get a different failure. You may remember I told you to put a pin in something and we return to it, and that's exactly where we are. Cannot read properties of null pointer exception effectively. So this is where we changed from event.target to event.detail. Seems like detail should work. It doesn't. One of two things is happening. Either I have a misunderstanding about how Lightning Web Components event dispatch works, or there's an inconsistency in it. And this is an open topic with Salesforce as well. I've left the question. We haven't discussed it yet. If you look at the documentation for the standard component library and you look at event handling in each component, some of them in their examples will say event.target and some will say event.detail. For now, stick with whatever it says. And so we're going to bring this one back to target, but now we have red again. And again, I'd like to get rid of red. So we're going to go ahead and just say we know this is a Lightning input, and now dot value is fine. So we're going to have to assert this to the right type instead of changing. Hopefully we get to a point where everything's, at least the standard component events, support detail, and you can just say dot detail and parameterize custom event by the standard component and start working with its state. But once again, let's go run here. And all tests pass successfully. So that's a move in the right direction. So there was one other thread that we left hanging right here, and that is these convert to async. So this is a suggestion coming from the TypeScript language service, and it includes a quick fix to do it. I have found that just the same way we saw that other quick fix with regard to changing required import broke something, sometimes these break something as well. So we're just going to do a couple of them, and that'll give enough to actually give an example of one that works and one that breaks. I think almost all the ones below break. We're going to rerun our tests, and we're going to see that we have one failure. So we made two changes, one of them is going to fail. And in fact, it is this. It is this right here. So something in changing from changing this to async has actually broken the behavior. And effectively, these quick fixes should have the same overall contract as a refactoring, which is restructuring code without changing the meaning of it, changing the behavior of it, but just making it so that it follows perhaps a best practice pattern. And that's obviously not what's happening here, because we just saw something fail just by virtue of applying it. So the reality is that you're probably going to want to be judicious in which of these you apply and just see which ones are taking a do no harm policy. Now, the thing that drives me crazy about this is, in reality, what I'd want to do is just suppress TS80006 for the places where it results in bad code. But this suggestion is coming from TypeScript language service, and TypeScript language service doesn't support any type of selective suppression. It doesn't support it by rule ID. It doesn't support it the way I'd want it, which is by rule ID on a particular line of code, similar to what we've done with some of these other static code analyzers. Microsoft is the product owner for TypeScript and TypeScript compiler and TypeScript language service. I did find there is an enhancement request open for exactly that, but it's unaddressed at this point. So the only way that you can turn these off if you don't want them is you can go into here and go into languages and frameworks and go into TypeScript, where the TypeScript language service integration is actually configured, and you can turn off show suggestions. And again, this is an external annotator, so what you're going to see is that it takes a second, but this will go green in just a moment. And the good news is that once it goes green, which it just did, is that these suggestions, while they're out of sight, they are not completely out of mind. So if I bring up context actions, they're still there. So this, I like to get things to green, and if I can't do it, it's going to drive me crazy. If doing so breaks the code, I'm probably going to go with this, and then when I know that I want to see if the TypeScript language service has something to offer, I'll just use context actions, because the JetBrains commercial IDE is already doing a lot. You already have ESLint, things like that. They all have selective suppression, disabling of reported suggestions, errors, things like that. But this does not. So I'm going to go ahead and just leave that off, and we can see that we've reached green, and we can run all of our tests, and we can see that they pass, and that'll kind of get us to closure on the porting phase. So we've ported it. What we haven't seen is we haven't seen it running in the org. We need to get it to the org. So that means that we need to do something, right? And that something is we need to compile it so that it can go to the org. And so this is going to be very important. I think most people know this, but TypeScript isn't really, it doesn't execute. Maybe there are executors for it, but in this context, it doesn't execute. You compile it to JavaScript, to ECMAScript 6. You deploy that into the server, and the server executes that just the way it has, or rather serves that out so it's executed in the browser since it's Lightning Web Components. But it basically works with that the same way it did your hand-coded ES6 types JavaScript. And that means that your TypeScript isn't even deployed to the server as part of the Lightning component bundle. I have an open question with Salesforce whether they're going to expand the notion of Lightning component bundle so that those get included for deployment. Because right now, if you deploy on one machine, you retrieve another machine, you lose a pretty important piece of information, your original source code, TypeScript source code. And so while this is really a prescribed best practice anyway, it becomes critical that these get mastered in an external system like version control. They should be already. The org generally should not be the system of truth, but it becomes even more important when the org doesn't even hold your original executable logic, your TypeScript files. So just saying that, so we have to get these into JavaScript form. So what I'm going to do, I'm just going to deploy Illuminated Cloud. You're going to see a pause here. That's actually a bug with JetBrains we're looking at, because the TypeScript compiler, the integrated one, can't be executed under the progress indicator. It actually bombs out. And so you saw a pause where there was no progress, but you can see that it completed. It compiled 17 files. It actually gets pretty quick. It just had to spin up that language service for the first time for compilation. And so, so it deployed. Everything deployed just fine. And that's great. What if there were errors? What do we get if there are errors? So why don't we take a look at that? I'm going to go back to the component that we ported, and I'm going to introduce like a broad set of errors. We can see by getting rid of the opening brace for the type itself, we get 63 errors here, and they're very visible in the IDE. You're not going to try to deploy something like this, but if you did, what happens? Well, the compiler is going to find these errors, and it's going to actually fail fast and not deploy. So we get all these, and they're directly linked to the corresponding line of code, things like that. But no deployment happened. This is all coming from the TypeScript compiler that's being run automatically on deploy. And by the way, any way you deploy, this is obviously a source tracked org because I'm doing a push. But if I were not against source tracked org, whether it goes against the tooling API or the metadata API, you're going to get the exact same thing. You're going to get the compiler first, and it's going to fail fast if it needs to. Let's see what a smaller scale error looks like. So we'll go over here and say product controller X, and again, we see this right here. It's saying that that's not a resolvable name, but I'm going to compile, and it should very quickly bring up an error for me, and I can see it, and it's of course linked directly back to the original code. Okay, so we can see that there's a pretty high gate you have to clear to get to a point where you even deploy. You have all the static code analysis and static type analysis and such, and in fact, it becomes difficult to just synthesize a server-side failure, because if I do this right here, API X is not a real decorator, we can see the error here, and I can go ahead and do a deploy, and it's actually going to short circuit again because the TypeScript compiler is going to say, hey, I don't know what you're talking about. So just to make this work, what we're going to do is I'm going to say suppress this, and it puts it up here. I don't know why. Put it down here, and then we're going to see the same thing I mentioned earlier where ESLint's going to say, so we'll just say forced error. And now everybody will go green, and I'm going to deploy. And even though that's a legitimate error, this is just like where I suppressed a false positive. It lets the TypeScript compiler ignore that and not fail on it. And now it's going to Salesforce. And Salesforce is going to end up reporting an error, and let's take a look at it, and it gets attributed exactly to the correct place in TypeScript. So now that is something worth calling out, because let's take a look. Now that we've compiled, there are .js files. You can see that they're ignored by the IDE, excluded by the IDE, but they're generated JS files. They've been added. If we look in version control, 17 files have been added to my change list. I'm going to go ahead and add those to the active change list, stage them, and that allows us to do something in just a moment. But what did it generate? Let's take a look. Let's compare the original source file to the generated TypeScript, generated output of TypeScript. And what we're going to see is that it is doing what you'd expect. It's stripping all the explicit type information, turning it into untyped vanilla JavaScript, and removing any imports that are no longer necessary based on what it's stripped out. And if we go a step further, we'll go over here to showing this in local changes, and I'm going to compare to our original JavaScript file. And what we're going to see is that, of course, it's APIX. Let's ignore that for just a moment. That's not our real code. But everything else, we have the original code. There's a white space break here. And there's a source mapping here that I'll talk about in just a moment. But otherwise, we're back at our original code. So this gives you a way to perform a sanity check and make sure that what's going to the server, what's going to be served out to the browser, that's going to execute in the browser, looks like what you would have hand-coded. You know, the white space may not be the same, but for the most part, it's what you hand-coded. And this error that was attributed right here, so we'll go back up here to the correct place in the error analysis, line 28, column 10. If we look at the JavaScript file, the APIX is actually on line 17. So Salesforce actually reported an error against line 17, column 10. Illuminated Cloud used the inline source map from the output of the TypeScript compiler to make it so that that's attributed back to the correct place in the original source, because that's all you care about. That intermediate JavaScript file exists just to make sure that things work. Hopefully that all makes sense. Let me know if not. But the point is you get error reporting in the IDE from all these static code analyzers. You get error reporting from the compiler. If things just don't compile, you get error reporting from the server that gets correctly attributed back to the original source and not what it saw, which is the compiled source, compiled output. And it's also, of course, worth mentioning that you saw that even though I just changed one file, it said it had compiled. In fact, we'll see it up here. It had compiled 17 files. They're all compiled together, and that makes it so if you make a change in one of your components and that breaks, that's part of the external contract, and it breaks something in another component, you would see that immediately. You would not have to wait until something breaks in the actual browser or something. So we'll go ahead and get rid of this. We've synthesized errors kind of all across, and we'll go ahead and deploy, and we should see that the compile takes a couple of seconds, and then we start deploying. So that took 3.5 seconds, not even 3.5 seconds, a little over 3 seconds, and everything's up to date. So that's great. Now let's actually look in the org, and let's see where we are. Is the app actually working? We ported it. Did we break a whole bunch of stuff? Hopefully not. So I'm going to go ahead and open up the org, and I'm going to go over here to the actual e-bikes app. And the splash page works. There's not a lot going on there. Let's actually go to the app itself. So here we have a lot of components in place. So everything looks good right now. Pagination works. If I want to see the details of one of these, that works. What if I start doing type down and say that works? What if I do type-based or price-based filtering? That works. I'm a mountain biker, so I want to focus on mountain bikes. That works. So for the most part, I'm not seeing any issues here. Everything seems to work. So this is TypeScript source, not direct JavaScript source. This is TypeScript source that created this. Now it's based on JavaScript source, and as you saw, the porting process was pretty straightforward. But that's pretty cool. So we have another way of actually showing things in an org. Let's go back over to our browser or to our IDE, and let's start the local development server. And let's start it for the e-bikes app. So this is obviously this was the last big feature, was tight integration of the local development server. So we're going to go over here to Product Explorer, and when we showed this last time, I showed that by changing an HTML template on the fly, you could see like filters change to filters mod or filters X or something like that. So let's split this over, and let's put e-bikes right over here, and let's give ourselves a little additional space. And what we want to do is see something functional. So we showed that type down filtering. Why don't we show, if we start typing a filter, we'll just do like a toast pop-up. So why don't we go to product filter component, that's this component right here, and search key, we have a handle search key change, and I'm just going to go ahead and say toast import dot show, And everything's very strongly typed. Everything's very well defined. So we'll go ahead and say that the label is going to be local dev changes, and the message is going to be the same thing that the user entered. So this dot filters dot search key, and we got to choose a variant. So we'll just choose, and we can see all the different kind of enumerated allowed values here. And there's one other thing we need, and we need a parent component for the toast. We'll go ahead and close this, and I'm just going to hit Control S, Command S if you're on Mac, to do a deploy on save. And we'll see down here that it'll compile, but it won't actually deploy. So it compiled, there's no deployment. And if I go over here and type DYN, we can see it's doing exactly what I just did. All right, I'm going to get rid of these so we don't see them as ghosts. I'm going to go over here and I'm going to revert this, and I'm going to save again, and we should see the results of another compile here. And we're going to go over here and say EL, and we can see Electra, and it's not showing the toast. So we now have a confluence of two very powerful features. We have local dev server, which is of course giving us real-time feedback on, and by the way, we have an unused import if you're wondering what that red is, because we got rid of the toast. We have local dev server, which is giving us close to real-time feedback on changes we make to content that resides in the browser. So your HTML templates, your CSS styling, your I was going to say JavaScript-based logic, but TypeScript-based logic. Ends up being JavaScript, of course, but you're maintaining it as TypeScript, and within like 3 seconds, you're seeing those changes and able to actually make changes to your application and kind of wash, rinse, repeat. And of course, on the flip side, you're using TypeScript as a higher level, statically typed, more full featured, I guess technically, because it compiles down to JavaScript. Anything you do in TypeScript, you can do in JavaScript. But there's more formality around some of the language features in TypeScript. But static typing is going to be the big one. You now have that available as a language. So that's the demo. That's what I wanted to show. Obviously, this is a long, meandering one. Hopefully, you've stayed with me. Like I said at the beginning, you're going to understand why I'm calling it beta, but you're also going to understand that it's very mature. I'm sure there are bugs. You find them, you let me know. If you look at the standard library and you see things that need improvement, that need to be filled in, let me know. Perhaps most importantly, because of the tight integration with the other features in the IDE, if you see regressions to non-TypeScript related features, let me know and I'll turn around things immediately. I certainly have done a lot of regression testing here, my kind of automated suite, and some kind of manual testing I have to do for some of the more complex corners, and I end up having to fix a lot of things. But I'm sure that there's a reasonable chance there's something out there. If you see something that's causing issues, let me know and I'll turn around a hot fix ASAP. I don't like regressions, and I like to address them as quickly as possible. Otherwise, I'll be interested to know what you think. Are you finding it useful? Are you ready to make the leap? Let me know. I'll be curious to hear what people are doing with it and whether it's working well for them. Otherwise, thank you very much for your time, and take care.